So, as we've seen previously, just looking at lots of scatter plots, and there's going to be quite a lot of them, is going to be quite hard. So actually, scatter plots are sort of the secondary thing that you need. Generally, you'd start with a heat map. So, heat map's going to tell them which products are correlated. So, if we want them side by side, what we can do, and this is a bit convoluted, but what we can do is add two plots together. We saw that last week, that if you add two plots together, it puts them side by side. So we can create a scatter plot. That's exactly the same as before. Then plus to add them together, and then this backslash just says there's a new line coming, but treat this, as far as Python is concerned, treat this as a single line of code. So that's the new bit of code. That's my heat map. So I get a correlation from that data frame. I create a heat map from it, and this is all very should be fairly familiar to you. So we can rotate the titles around by 90 degrees, put the cool warm color map on, and I've inverted the y-axis, which means that it goes which order it is. Yeah, it goes diagonally down from the top left to bottom right. Okay, so that plus just adds them together, and the backslash lets them know that the thing being added is on the next line of code. And so the controlling code actually is completely unchanged. The heat map in this case is not controlled by any widgets, so there's no information that needs to be passed in to the function that creates the plots, because it's just creating a heat map with no controls, user controls, and a scatter plot, which is controlled by the user. And that's the resulting code. Let's just run that. Just to show what would then be possible. So as a user, I can then see, okay, there's a high correlation, H&M. We looked at that one before, at H&O, or M&O. It's got what's that point? H&O looks quite high. Let's do H&O. Or I can see a strong negative correlation there with S and J. So it's a very nice interface for the user to look at the strongest correlations. Perhaps I should put these the other way around. Maybe I should put the heat map first. They look at the correlations, and then they select which ones they want to view. Select which square. Effectively, each one of these scatter plots is just viewing one of these squares, and indicates what the correlations are. We can also, and this is quite a thing we haven't done before actually, we can put a date slider on this. So we could restrict the date range. So, for example, the data might be more correlated with other data. One column might be more correlated with another, or one product might be more correlated with another in a particular time of year. Okay, so I can pass in a date range, which is just like the previous example with the line plots, and I can then restrict the data frame to that particular date range. And the controlling code is the same before, except we create a date range slider like we did in what was example 3 or 4. Add it to the page and watch that as well. And then if we look at over a particular range of dates, we will see differences in the correlations. So let's look at that example. So there's the default correlations. If I squash that down to June, let's say the 1st of April to 30th of June, quite difficult to control that, which was what I showed you on the slide. You'll see there's some blank columns. That's telling us that the data in those columns is all zero. So as you may remember, D has no values for the first half of the year, and G drops out for the second quarter. So they're all zeros. But now you can see the stronger correlations there they're coming from H and O again. So there's no big change there. But A and J are now correlated reasonably well, not particularly well. We've got H and O, but M is no longer particularly strongly correlated with H and O. It's much the correlation between M and O is much less strong. As you can see from that chart, which suggests that if we went to a different point in the year, I'm not going to do it. You can explore this yourself. But if I went to a different point in the year, maybe M and O might be more strongly correlated in another part of the year, since they're more strongly correlated than that in general. Okay, so that's allowing us to really zoom in on the correlations using the date slider as well, to find out when in a particular point of the year, if the correlation is throughout the whole year, or if it's for a particular set of dates, if it's stronger for a particular set of dates. So let's finish that video there, and then we'll move on to allowing the user to select variables from the summary data.